Okay, so let's go to the modeling of regular building. Building modeling. So set the unit as length and next one force as kilonewton next. So in the present case I am going for a more present modeling of an irregular building. So here, which consisting of this plan, the plan is 15-meter length. So in Staad, xz will be the plan, xz plane will represent the plan. Here the in x direction there is a 15-meter length, so number of bays are 3. In z direction there is a 16-meter, the number of bays are 4. And when it comes to height, so totally there is 15 meters, there are 5 bays. And this is my 3D view, and I'm going to assign the property beam size as 200 by 400. And we can see this from the diagram that so beams are parallel to x and z axis. In the same way, I'm going to assign a column size 200 by 400, which are parallel to the y axis. We can see this columns are parallel to the y axis. And my main objectives are, so the objectives of my this current video is to model a regular plan building frame using the geometry range structure wizard command and assign M20 concrete. Here I'm not defining exactly I'm not giving the name as M20. Instead of this one, I am giving the mechanical property of the concrete, that is elastic modulus of M20 concrete is 22360 when it expressed in Newton mm square. When it is converted to kilonewton bar meter square, it comes to be 2.236 into e to the power 7. And also the density of concrete, I will take it as 25. Later after this, I will assign the self weight and check the base reaction and compare with a manual calculation. Okay, so compare the result with manual calculation. Let's go to the video now. Let's go to the video now, and this is what I'm going to do. So go to the regular take it as a space frame because it is a 3D building. Regular building model stat classes it will be saved in this folder, meter and kilonewton. Next, go to open structure wizard directly and finish. So here model type is frame model, bay frame, length was 15 meters and number of bays along length is 3, and height is equal to 15 meter, and along the height there is 5 bays, and next in width wise it is 16 meter, number of bays along width were 4. Okay, now you can see the dimension also 5 5 5 here, and here it is in the height wise there are 5 bays and 3 meter each, and in this x direction there are 4 4 4. Okay, the model is correct, I think. So click on this apply, go to file, merge model with stat row. Would you like to transfer? Yes, I want to transfer at location 0 0 0. So the material has so model has been imported. Then after this one, I need to check whether the dimensions what we adopted is correct or not. So for this, go to the tools, display node to node distance. From here to here it should be 15 meter, from here to here it should be 16 meter, and when it comes to single bay, so here it should be 5 meter along x direction, here it should be 4 meter, and when it comes to height it is total is 15 meter, and height of this one is 3 meter. Okay, so go to tools, and to remove this one, remove node dimension. Okay, so modeling is correct, but still I want to we will so next thing is we need to assign the concrete material. So to assign the concrete material, go to this general tab. Here you have material in that choose concrete, assign to view, assign, yes. Okay, now by default concretes, it takes the stat takes you the elastic modulus as 21,718, Poisson's ratio as 0.17, and density expressed in kg per meter cube, it is 2410. So this value we have to change. To change this value, I had to go to edit input command file, save, and go to the define material. Here E value, as I told, it should be 22360. That is, when it expressed in kilonewton per meter square, it is 2.236 e to the power 7, and density of concrete is 25. Save and close. Now you see this 22360 when it is expressed in this one, it is nothing but it is divided by, when it is expressed in kg per meter cube, it comes to be nearly 2549. Okay, next I had to select beams parallel. I had to use the properties, that is the beam properties are here are my beam properties. Beams are made up of 200 to 400, columns are made up of 200 to 500. We can also see this beams are parallel to the x-axis and z-axis. You can see this diagram. Beams are parallel to x and z-axis, and this dimension is 200 into 400, whereas column is parallel to the y-axis and 200 by 500. So go to property, define a rectangle. Depth is, first I will define the beam 0.4 by 0.2, and next one is 0.5 by 0.2. Okay, so reference number 1 is going to be assigned for beams which are, now we can see the global axis here, x is here, z is here, that is beams are parallel to x and z. So what I have to do is I have to find an option, select beams parallel to x and z. So go to select beams parallel to x, as well as select beams parallel to the z, assign to selected beam, assign, yes. Okay, next select beams parallel to the y. So select the reference number 2, go to select beams parallel to y, assign to select beam, assign, yes. Okay, now after this one I want to see this in 3D render view. Go to view, 3D render. So you can see this model has been created. Okay, so so after this one we assign the loads. So to assign the load, go to load and definition. That is the load I want to assign. Just I want to assign the self weight and check base reaction, compare with manual calculation. Okay, so go to in order to assign the self weight, go to load case detail, add. So loading type, it is a dead load, DL. So name it as, in the short I will make it as DL, add. So in the DL, go to the add. Here you go to the first command, is the first command when you open this thing is self weight acting in y direction, that is it is acting in the y direction. Factor is -1, it indicates it is acting in the gravitational gravity direction. So that's what we use, -1 factor, and acting in the y direction. Add, close. Okay, so I had to assign this to the complete structure, that is self weight of, I want to assign self weight of beam and self weight of beam and column only. That is in the present structure it consisting of self weight of beam and column only. So I will assign only the self weight of beam and column. Okay, so assign this to view, assign, yes. Okay, next step is to assign some support and run the analysis and check the base reaction. Okay, so go to support, create a fixed. Okay, so the support 2 will be there. So it is very difficult to select each support like if you see it from the 3D. So what I had to do is I had to see it from the diagram from the front view, select all the nodes. So the nodes that are behind these points will also be selected when I see it from the front view. So go to the front view here. Now you go to the support to select these nodes. So we can see this backside nodes are also selected. Now use an assign to selected node, assign, yes. Okay, so next step is you have to choose perform analysis. It has to go for linear analysis. So for this, go to command analysis, perform analysis. Now in this problem I want to see what is a static check, means click on the static load. Okay, then go to analyze, run analysis, save. To see the self weight of the structure, you can go to the view output file, and applied load, you have applied totally 2140 kilonewton load. Okay, reaction will also be the same. Reaction will also be the same. Okay, so we can also go to the post processing. Here in this reaction, here there is static check result is there. You have applied the load is 2140 and the reaction is also 2140. Now we will check this one with our manual calculation, how much I should get. Okay, firstly I will come into the self weight of the beam. So length of the beam, if I take the dimension here, okay, so it's okay. Okay, now we can see this. So length of the beam parallel to x-axis is totally we have, so 1 2 3 4 5, so 5 multiplied by 5 it is 75 meter, and length of the beam parallel to z-axis are 1 2 3 4, 4 into 16 it is 64 meter. Total length of the beam that comes to be 75 plus 64, which is equal to 139. And we know that self weight of the beam is given by cross section multiplied by the density of concrete when it is expressed in kilonewton per meter, but I want to take the result in kilonewton, means multiplied by length of the beam. So 0.2, I given the beam size 0.2, 0.4, 25 the density of concrete. When it's multiplied by 139, we'll get the, for one story 278. So we have assigned this column for we have assigned this beam for 1 2 3 4 5, so we had to multiply with the 5. So due to self weight of the beam, total self weight of the beam, it comes to be 1390. Next I want to see the I want to check the self weight of the column. Here in this problem, if you observe this one, I given the column at all the points. So there are 20 columns here, and the height of this column is total it is 15 meter. Height of this column is 15 meter. So number of columns are 20. Length of the column is, length or height of the column is 15 meter. It is also in the same manner. So be it cross section multiplied by density into length of the column multiplied by the number of columns. So 0.2, 0.5, 25, 15 into 20, that gives you 750. And now when you add up this together, so first one is the self weight of the beam 1390, self weight of the column is 750, overall together it is 2150. This is all we wanted to do these things. Okay, so all my objectives are clear. This is how we can model the simple building, as well as, so the main why I'm doing this base reaction is to check the model, whatever it did is correct or not. You may have done the length, we may have given the length or width properly, but you may not given the you may not have given the density properly, or you may not you have given the wrong section. All these things can be verified when you go to the base reaction. So it is very important to get the base reaction correct in any software, whether you do it in this Staad or in ETABS or in ANSYS or anything. It is, first thing is to search what is the base reaction. Once you know the base reaction, so you can come to the conclusion that whether what you're doing is correct or not. Okay, here base reaction is also called, actually in Staad it is called static check result. In ETABS it's called as actually base reaction, and in this it is called static check results. Okay, so this is about all these things. That is static check is also called base reaction. In ETABS it is here in this problem it is I had to check the static check. I had to perform static check result, and that is nothing but a base reaction, and calculate this manual calculation. You can see this. Yes. Okay, now you can see this. It is 2140. So we have assigned the load as sulfate. And this is what about my this one. Okay. Okay. Thank you for